So basically, this summarizes everything that we've talked about when it comes to factoring, okay? And the first thing we've got to do is always look for the GCF, okay? So before we do anything else, we want to determine, is there a GCF? Then to factor polynomials, we've got some clues. Actually, the number of terms is the clues we're looking for. For example, if it has two terms, then it could be a difference of squares. Difference, of course, being a subtraction of squares. If it doesn't have two terms and a subtraction sign, there's no way that it can be a difference of squares. We're going to look at these examples and work these in just a minute. Well, if it's got three terms, and we already know how to factor a trinomial where the coefficient is 1. Of course, we always look for that GCF first, but then the key to it is finding factors of the constant. Two things that multiply to be this term, but will add up to be the coefficient of x. That's the key. It's really pretty easy. Sometimes three terms will have a coefficient in front of x squared. If so, we're going to use that slip and slide or slide and divide, whatever you want to call it, method to factor. Finally, if it's got four terms, we know how to work those, and we factor by grouping. We did that a while back. So let's look at some examples. First of all, if it has two terms, take this example and write it down. X squared minus 64. Well, it's got two terms. The GCF is 1. So this is a square. The x squared is the same thing as saying x times x, and 64 is the same thing as saying 8 times 8. And it is a difference of squares. There's a subtraction sign there, so all that's good. So this will factor then to be x minus 8 times x plus 8. And remember, it doesn't matter which one comes first. Let's look at the second example of a two-termer. This one is 18m squared n minus 2n cubed. First thing we need to check always the GCF. Well, we've got 2 and 18. Choose the smallest number and we'll divide evenly to 18. So my GCF will be 2. Also, I've got an m squared. I've got an n. I've got an n cubed. Well, there's no m in the second term, so that's not part of the GCF. But there is an n in both terms, and I can factor out one of those n. Remember that n is into the first. I'll take the lowest power. So when I factor out the GCF, hope you're writing all this down. When I factor out that GCF, I'll be left with n m squared minus n squared, because 2 divided by 2, 1. N to the third divided by n squared. So I just remove an n there because I factored it out. Alrighty, so 9m squared is the same thing as saying 3 times 3 and m times m. So that's a squared term. And n squared is the same thing as saying n times n. All right, so to finish up the factorization here, it's going to be 2n. And because it's a difference of squares, it's 3m minus n, 3m plus n, and then I'm done. But what if it's three terms? Well, there's two situations with three terms. Let's look at an example here first of x squared minus x minus 42. All right, greatest common factor, the GCF there is 1, so we don't have to do anything. That's cool. Coefficient here is 1 as well. So what I want to know is what are a couple of factors of 42? Now, it's negative 42, meaning one factor will be negative, the other will be positive. Let me write down those factors real quick. So factors of 42, 1 times 42, and one will be negative, the other will be positive. I want to use some clever thinking here. I know since one's positive and the other's negative, then and my middle term is negative, my larger term is going to need to be negative. Because when I subtract those, I get negative 41. I'm looking for negative 1. So let's keep going. 2 times negative 21. You know, I just happen to know or remember that 6 times 7, okay? 6 times 7 is 42 as well. And if I make the 7 negative, that's going to give me, if I add those two, sum of negative 1. That's what I'm looking for. So this will factor to be x minus 7 times x plus 6. Pretty straightforward in my trinomial. Let's look at one more example of a trinomial. Another 3-term trinomial. Trinomial has to be 3 terms. 2w squared plus 20w plus 50. Well, let's see. We've got 2, got 20, I've got 50. Smallest coefficient there is 2, and 20 and 50 both will divide by 2 because they're even numbers. So my GCF here is 2. So I've got to factor that out. I'll get w squared plus 10w plus 25. Interestingly enough here, that's a perfect square, and the square root of that's 5. If I say times 2, that'll give me 10w. So that's actually a perfect square trinomial. But even if I didn't see that, I can still factor it in the way that I'm used to. What are factors of 25? The positives are going to both be positive, both be negative. But since the center term is positive, then they'll both be positive. What factors of 25 will add to be 10? Well, I know 1 times 25, if I add those, I get 6. But 5 times 5 is 25. And that gives me a sum 10. Right, so that's what I'm looking for. So either way I want to factor it, I can factor it recognizing it's a perfect square trinomial, or I can just factor it as a standard trinomial. I want to write it mathematically in the best way. So I'm going to write it w plus 5 squared. Let's look at another 3-term example. This one is 30x squared minus 27x plus 6. Well, the GCF here, the smallest coefficient or smallest number here, 6. 6 won't divide 27, even though it will divide 30, but 2 times 3 is 6, and 3 is the next factor down. 3 would divide 6, 27, and 30. So my GCF here has to be 3. X squared x, no variable, so no variable portion of the GCF. So I need to factor that out. It's going to be 3 times 10x squared minus 9x 3 times 9 is 27 plus 2. And if you remember, even after you factor out that greatest common factor, got that pesky coefficient of 10 here on x squared. So that's a slide and divide, or whatever you want to call it, slip and slide. So I'm going to rewrite it as 3 times x squared minus 9x plus 20. Because I multiply 2 times 10. And so now what I need to know, factors of 20. Now, notice 20 is positive, but my center term is negative, meaning that both factors of 20 are going to have to be negative. So I'm not even writing the positives down, but factors of 20 would be negative 20 and negative 1. Could also be negative 2, negative 10. 3 won't multiply by 20, but negative 4 and 5 will. And negative 4, negative 5, when I multiply those two, multiplies to be a positive 20, but has a sum of negative 9. That's what I'm looking for. Bingo. So remember how to do the factorization, and my factorization is going to be x minus 4, x minus 5. Don't forget, because I multiplied by 10, I have to divide by 10 as well. In this case, this is one of those where I must reduce those fractions before I do anything else. So it's x minus 2/5 and x minus 1/2. So final answer here, once I simplify that binomial, remember, multiply through by 5, and I'll get 5x minus 2 and 2x minus 1. That's my factorization of 3x squared minus 27x plus 6. So don't forget to bring down your greatest common factor. 3 times 5x minus 2 times 2x minus 1. The very last example I want to look at takes us back a few days. We did this last week, but it is a 4-term polynomial. All right, so it is this one, 2a to the third. Now remember, this one has 4 terms, and if it has 4 terms, then it's probably going to be factor by grouping. It could be prime, but everything that I'm probably going to give you is going to be a factor by grouping. So remember how we do the factor by grouping. You're just going to pair them off into 2 sets of binomials, just like that. Oh, I should check for the greatest common factor before I do anything, and easily done for me to forget that, but I can make a major mistake with it. I've got 2, I've got 1. Well, here's a 1, so greatest common factor is 1. I got A, no B, B. So there's no variable portion. So the greatest common factor is 1. I'm safe. Okay, so now I compare it off into 2 sets of binomials. And I'm going to pull the greatest common factor out of each individual binomial. So the first thing I want to look at, really, is just the 2a to the third minus a squared b. I can factor out an a squared. But there's no constant I can factor out, so I'll be left with a was a 2a, that is. A times a is a cubed, and 2 divided by 1 is just 2, minus b. Because a squared divided by a squared is just b. When it's a squared b. So a squared b divided by a squared is just negative b. Now remember, I mentioned to you back when we did this that if this is going to factor by grouping, there's a good hint right there that this next binomial should look a little bit like 2a minus b. And I can see that I can factor out a 5 from 5 and 10, but there's no variable to factor out. So let me factor out that 5. So 10a divided by 5 is 2a. And negative 5b divided by 5 is negative b. And I want that to look like the other binomial. Sure enough, it does. So factored then, it's a squared plus 5 times 2a minus b. And that's the factorization. So remember, the key here is that it's all dependent. We go to factor on, after we take that GCF, how many terms are there? 2, 3 terms, or 4 terms? And then depending on the number of terms, it's going to dictate how do we factor that polynomial. And that's what you need to know for the test tomorrow.